Hi everyone, this is Jim Martinez once again. Today's topic is going to be understanding the atomic mass and the structure of atoms. This is the 8th grade science channel. In correlation with our TEKS 8.5a, which is to describe the structure of atoms, including their mass, electrical charge, and location of protons and neutrons in the nucleus, and electrons in the electron cloud. From previous knowledge, we have learned that parts of the atom, like the nucleus and the electron cloud, which are the two main parts of the atom. We also have learned the electrical charge and mass of subatomic particles. For example, the protons, and the protons had a positive charge, and their mass was 1 AMU, or atomic mass unit. The neutrons don't have any charge. That's why they're called neutral, or neutrons. But they also have 1 AMU, or 1 atomic mass units. The electrons have a negative charge, and they're very small, that we consider them not to have any mass. Or at least they don't count for mass. We also have learned about the atomic number. Like, the meaning of the atomic number is actually the amount of protons inside the nucleus of the atom and the amount of electrons outside of the nucleus on the electron cloud. So let's get to the point. What is the atomic mass? The atomic mass is considered the weight of subatomic particles in atoms expressed in atomic mass units, or AMUs. It is also equivalent to the number of protons and neutrons inside the atom. So we got protons and neutrons in the atom. They're also located inside the nucleus of the atom. Okay, so keep that in mind. Where do we find the atomic mass of an atom? We find them in several places. It's found under each element in the periodic table, and it's found in numerical form. It's also found in the nucleus of the atom in particle forms. As you can see in this example, the bottom number here, that will be 6.941. If we round it up to the nearest whole number, that is going to count for 7. And that is the atomic mass in numerical form, which is the way we find them in an element in the periodic table. If we look at this example over here, this is boron. You can see the symbol on top. In the middle, we can see the atomic number on the top, and this is the number that we're concerned with on the atomic mass, which is 10.1. And if we apply this concept of rounding to the nearest whole number, this number will be equals to 11 AMUs. So as you can see, every element is going to have underneath the symbol the atomic mass. So here I'm circling a couple of examples, so you can keep that in mind. Okay, so how do we find the atomic mass? So it's very easy. Actually, we have to add protons plus the neutrons. Let's practice this. Okay, remember this formula right here. Protons plus neutrons is equals to atomic mass, right? So if we add that formula over here, we're going to see, or inside the nucleus, we are going to have, remember this, we round it off, and that will be equals to 11 AMUs. So we can have 11 particles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. And out of those 11 particles, 5 of them are going to be protons, as we have seen this concept on a different video. So 5 of them are going to be protons. 3, 4, and 5. So there you go. If we have, remember this formula, protons plus neutrons is equals to the mass. So if we put the values over here, this will be 5 protons, which comes from this number right here, plus whatever neutrons should be equals to this number, 11. Okay, so let's see if it's true. We got 1, 2, 3, 4, 5, and 6. All right, let me see. 5 plus 6 is equals to 11 AMUs, and that is correct. Put a check on this one. We're good to go. Fluorine. We have fluorine over here. Once again, we have a number. Underneath the atomic symbol, we have 18.998. So if we round that off, that is going to be equals to 19 AMUs. So this is the total amount of particles that we can have in the nucleus. So we put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19. This is the amount of particles that we can have in the nucleus of the atom, right? So this is inside the nucleus of the atom. That is an ugly nucleus. As you can see, this circle, usually I make very good circles, but this one came completely off. Okay, out of this, 9 of them are going to be positive. So we're going to choose 9. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we should have, once again, protons plus neutrons should be equals to the atomic mass, to 19 AMUs. Right, so how many protons do we have? We have 9 plus whatever number should be equals to 19 AMUs. Well, let's see if it's true. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So let me see. 9 plus 10 should be equals to 19. Is that true? Yes, it is. So inside the nucleus of the atom, we got our atomic mass, which is 19 particles, which is stated right here on the bottom. This is sodium. As you can see, it just keeps getting bigger and bigger. Now sodium is going to have, if we round this off, it's going to be 23 AMUs, right? So we are going to put 23 different particles. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, and 23. Out of these 23, once again, this is the atomic number, which means that we are going to have 11 protons. So we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So we have 11. Remember that protons plus neutrons should be equals to 23 AMUs. All right, so we have 11 protons plus, how many neutrons is that? Well, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. We should be, oh, here it is, 12. So 11 plus 12 should be equals to 23 AMUs, and this one is also correct. Remember, this is inside the nucleus of the atom. Now let's find the atomic mass of an atom. By looking at this atomic structure, we should be able to figure out which element is this and what is the mass. So the mass is very easy. First of all, let's take a look at, here we're going to have the symbol, and on the top we should have the atomic number, and on the bottom the atomic mass. So if we count over here, this is 1, 2, 3, 4, 5, 6. We got atomic number 6. And then here we have 7, 8, 9, 10, 11, and 12. So the bottom number should be 12 AMUs. Okay? If we look at the periodic table, we are going to find out that this one should be a carbon. There it is. It's going to be a C with a 6 on the top and a 12 on the bottom. Right? So that's it. That's how we find out, just by counting the elements in the middle. All right, let's find out this one. Now, here, what will be the atomic mass of this element or this atom? Well, we're going to have to count the total of all the particles inside, remember? So let's start with all the yellow ones. All right, let's start with the red ones. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we have a 10. That will be the atomic number because these are the protons. Now, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we also have 10. So remember, adding all together 10 plus 10, remember the formula. Protons plus neutrons is equals to mass, right? So here we got 10 plus 10 should be equals to 20, right? So that is 20, and that must be neon. All right, let's take a look at the last one. And here we have 1, 2, 3, 4, 5, 6, 7, 8, and 9. Here we got 9 AMUs in total, and 1, 2, 3, 4. 4 of those are protons, and this element should be boron or beryllium. It should be beryllium. All right, so remember, these are the formula. Protons plus neutrons should be equals to 9. So we have 4 protons plus, we got 5 neutrons, and 4 plus 5, that is equals to 9 AMUs. And this is correct, and this one is correct too. What have we learned today? Well, today we learned that the atomic mass are the total amount of particles inside the nucleus of the atom, that adding protons and neutrons equals to the atomic mass, and the atomic mass is the number underneath the element's symbol. Well, that's all for today. Thank you for watching. This is Jim Martinez with the 8th grade science channels. Bye-bye.